Let's look at question number 7 now. In question number 7 we have Bertrand duopoly with price equals to 10 minus q. So let me just write down this equation. Price equals to 10 minus q. This is your demand function, q demanded. Okay. The market is equally shared if they charge the same price. Otherwise the lower price firm gets the entire demand. Firm must satisfy all the demand coming to it. The cost function of firm 1 is 3q1 and that of firm 2 is 2q2. Okay, so the cost function is c1 is equals to 3q1 and c2 equals to 2q2, which implies marginal cost of firm 1 is 3 and marginal cost of firm 2 is 2. Okay. Suppose prices vary according to the following grid 0, 0.1, 0.2 and so on, then the Bertrand equilibrium is given by. So you cannot charge any price, any real number price, you have to charge in multiples of 0.1. Okay, so you can just charge in multiples of 0.1. So let's look at the different options. So the best way is to look at options and check if there is any incentive to deviate. Check for incentive to deviate. Okay, so if both the firms offer a price of 2, okay, so the strategy is check for incentive to deviate from given options. Okay, so option A is PA equals to PB is equals to 2. So this implies that pi A is equals to pi B is equals to 0. Sorry, pi A is equals to pi A is negative and pi B is equals to 0. Okay, so in this case firm A can deviate to price greater than 2 and get 0 demand and thereby 0 prices, thereby 0 profits. Okay, so firm A is getting negative profits, which is not good, okay, because marginal cost of firm A or firm 1 is 3. Okay, so that's not good for firm 1. So this is definitely not Pareto efficient because firm 1 can deviate. Similarly here firm 1 is offering a price of 3, firm 2 is offering a price of 2. So in option B you have PA is equals to 3 and PB is equals to 2. So both firms are getting 0 profits. So firm B can charge higher prices and still get positive profits. Not still, get positive profit. Okay, so it will get positive profits. Okay, so there exists an incentive to deviate here as well. So this is also not your Pareto efficient case. Let's look at case D now. Both firms charging price of 3. So in this case firm 2 is getting 0 profits and firm 1 is getting positive profits. Okay, so case 3 is case C is PA equals to PB is equals to 3. So you get firm A with marginal cost of 3 gets a positive profit of 0, and firm B it will get some positive profit. So what's going to be the demand? So at price level 3, quantity demanded is going to be 7. So QA equals to QB is equals to 3.5. So profit of firm B is going to be 3.5 times 3 minus 2. So that's going to be 3.5. So it's earning a positive profit of 3.5. But let's say it deviates to PB is equals to 2.9. It slightly deviates to PB equals to 2.9. Then what will happen? Is that quantity demanded, the entire quantity demanded becomes 10 minus 2.9, so that is 7.1, okay, which becomes equal to quantity demanded from firm B, okay, because it's offering the lower prices, implies gets entire demand, okay. So in this case, profit of firm B is going to be 7.1 times 2.9 minus 2, so that's 7.1 times 0.9, which is roughly equal to 7. So it will get roughly around 7, which is definitely greater than 3.5. So therefore firm B has an incentive to deviate. Therefore this is also not a Nash equilibrium. Okay, this was option D which I was checking. So the only option remaining is option C. Option C, PA equals to 3 and PB equals to 2.9. This is a Nash equilibrium since we have ruled out all other options. One can check different possible deviations and satisfy themselves. Okay, I'm not going to the algebra of this because obviously it's unnecessary, but you can go through the algebra and you can find that given this level of prices, the best option for agent 1 is going to be to stick to 3 and agent B is going to be to stick to 2.9. So you can do your algebra, you can satisfy yourself. Okay, so this is your final answer.